Picture this. You're standing on top of a massive skyscraper, looking down at the city below. It's a breathtaking view, but here's the real mind-blower. How is this giant structure standing tall, defying gravity without toppling over? What's stopping it from swaying like a tree in the wind or crumbling under its own weight? The answer lies in a fascinating concept called statics, and specifically, the equilibrium of structures. This isn't just about buildings, it's about the hidden forces that keep everything in balance, from bridges to roller coasters to the chair you're sitting on right now. So, what's the deal with statics? In simple terms, statics is the branch of mechanics that deals with bodies at rest. Think of it as the art of keeping things perfectly still and perfectly balanced. We're talking about structures that aren't going anywhere, buildings, bridges, towers, that need to stay upright and stable, no matter what forces are thrown their way. And when we say equilibrium, we're talking about a state where all the forces acting on a structure are perfectly balanced, so nothing's moving, nothing's tipping, and everything's holding steady. Sounds simple? It's anything but, and that's where the magic happens. Let's break it down. Imagine you're playing Jenga. You know the drill. You carefully remove one block at a time, trying to keep the tower standing. But what happens when you pull out that one block that messes with the balance? The whole thing comes crashing down. That's a perfect example of what happens when equilibrium is lost. In the world of statics, our job is to make sure that doesn't happen. We want every structure to be as stable as that Jenga tower before you start messing with it, balanced, solid, and ready to withstand whatever comes its way. Now, let's get into the nuts and bolts of it, forces. Forces are the invisible push and pull that everything in the physical world experiences. They're the reason why things move, and in the case of statics, they're the reason why things don't move. For a structure to be in equilibrium, all the forces acting on it have to cancel each other out. It's like a perfectly balanced scale. If one side is heavier, the scale tips. But if both sides are equal, the scale stays level. In statics, we're aiming for that perfect balance, where all the forces add up to zero, and the structure doesn't budge an inch. But it's not just about forces. We also have to think about moments, the tendency of a force to rotate an object around a point. Imagine pushing a door at its hinge versus pushing it at the handle. Same door, same force, but a completely different result. That's because the moment depends not just on the force itself but on where and how you apply it. To keep a structure in equilibrium, you've got to make sure all the moments are balanced too. It's like making sure all the kids on a seesaw are perfectly balanced so no one ends up with a face full of dirt. So, why does this matter? Because understanding statics and equilibrium is crucial for anyone who wants to build something that lasts. Whether you're an engineer designing a bridge or just someone trying to build a sturdy treehouse, getting these principles right is the difference between success and disaster. Think about it, every time you cross a bridge, step into a skyscraper, or even sit on a chair, you're putting your trust in statics. You're relying on engineers to have done the math, balanced the forces, and ensured that everything stays exactly where it's supposed to be. But here's where it gets really interesting. Statics isn't just about keeping things from falling over, it's about efficiency, elegance, and even creativity. The best structures aren't just stable, they're designed with an understanding of how to use the least amount of material for the maximum strength. That's why some of the most iconic buildings and bridges look so sleek and simple. Behind that simplicity is a deep understanding of statics, allowing engineers to create structures that are not only safe and stable but also incredibly efficient and beautiful. And let's not forget about the hidden forces at play. Gravity is the big one, constantly pulling everything down toward the earth. But there are other forces too, wind, earthquakes, the weight of people and objects inside the building. A structure in equilibrium has to withstand all of these without flinching. It's like being in a constant battle with the forces of nature, and equilibrium is the key to winning that battle. So, what's the takeaway? Statics and equilibrium aren't just abstract concepts, they're the foundation of everything that stands tall and proud in our world. They're the reason why your house stays up, why bridges don't collapse, and why architects can dream up ever more daring designs. Understanding these principles gives you the power to create structures that are not only strong and stable but also push the boundaries of what's possible. Next time you're in a tall building, crossing a bridge, or even stacking up some blocks, take a moment to appreciate the forces at play, the delicate balance that's keeping everything in place. Statics might be invisible, but its effects are everywhere, shaping the world we live in and the structures we depend on. And now that you know the secrets, who knows what you'll build next?